determined, you require a minimum of 2 equations. So the first boundary condition I introduced was when t is equal to 0, q is equal to 0, I ended up with one equation. Now what can be the possible next boundary condition? The next possible boundary condition can be when t is 0, I is also equal to 0. This can be the next boundary condition. The problem with us is we have an equation only in terms of q. We do not have equation for it. So what do? We differentiate this equation for I is equal to dq by dt. Therefore, minus b plus root of b squared minus k squared into see, I have just done simple differentiation, sir. Plus minus b minus root of b squared minus k squared into b e to the power minus b minus under root of b squared minus k squared into t plus q naught. This is the equation for q. I have differentiated. Now let me substitute the boundary condition. 0 minus b plus root of b squared minus k squared into a plus minus b minus root of b squared minus k squared into b plus q. Right? We have to simplify this. Let me rub this off. Minus b is here, minus b is here. 0 is equal to minus b, therefore I will take a plus b. Then I have under root of into a minus b. Okay, plus q naught. Plus q naught is there. Am I right? No, I have to differentiate now. If I differentiate a constant, how will I get this constant? It will be 0. A constant, if it is differentiated, is 0. This is the equation. Therefore, there is no question of plus here. Now, a plus b is minus q naught. Minus of minus plus q naught plus root of under root of b squared minus k squared into a minus b. So the equation I get is a minus b is equal to minus b q naught upon under root of b squared minus k squared. This is equation 6 for me. This is equation 6 for me. Is that okay to you? Now, this equation and this equation can be solved to get the values of a and b. Therefore, I will write solving equation 5 and 6. We get the value of a I get is a is minus q naught by 2 into 1 plus b upon under root of b squared minus k squared. This is the value of a I get. Similarly, b I will be getting minus q naught by 2, 1 minus b upon under root of b squared minus k squared. I have not derived this, I have just said by solving equation 5 and 6, we get these two equations. What I am going to do now is substitute the values of A and B in equation 4. So I will rub this off. Okay? I will rub this off and show you how do I arrive at equation 7. Is that okay to you? Now, listen here. This is the value of A. Q is equal to minus Q naught upon 2, 1 plus B by under root of B squared minus K squared into e power minus B under root of B squared minus K squared into T plus. Again B is minus Q naught by 2. Am I right? Therefore, minus Q naught by 2, 1 minus B by under root of B squared minus K squared into e power minus B minus under root of B squared minus K squared into T plus Q naught. Don't worry, we'll simplify this beautifully. As you can see, minus Q naught by 2 can be taken out. I have taken it out. Therefore, I end up with 1 plus B by under root of B squared minus K squared into e power minus B plus root of B squared minus K squared into T plus bracket open 1 minus B under root of B squared minus K squared into e power minus B under root of B squared minus K squared into T plus Q naught. And I will call this as equation number 7, sir. This is an expression giving you Q. This is the expression which is giving me Q. Now, I have to analyze this expression 7. How do I do that? How do I do that? I will tell you how I proceed further. Okay? Now, let me rub this part off. Okay? If you look at this expression, everywhere we have a B squared minus K squared, and we all know what is B squared and what is K squared. I will let you know what it is exactly now, right? Now, sir, special cases. First case is this case, when B squared is equal to K squared. When B squared is equal to K squared, what does it exactly mean? R squared upon 4L squared is equal to 1 upon L squared. This is what it means. Okay? Now, we will try to substitute this expression. Q is equal to minus Q naught by 2, bracket open, 1 plus. If I substitute B squared is equal to K squared, denominator becomes 0 and it becomes infinity. So I am not going to, then solving the expression becomes very difficult for me. And therefore I am not going to substitute here B squared minus K squared in the denominator. Instead I am going to cancel it out in calculation. Let us see how it is. B by under root of B squared minus K squared. Here, if B squared is equal to K squared, this part becomes 0. Therefore, this reduces to e power minus bt. Exactly in a similar way. Plus, I will write it here. Plus 1 minus B by under root of B squared minus K squared e power minus bt, bracket close, plus Q naught. Okay? Okay? Now, e power minus bt is common, can be taken out. Therefore, this becomes q is equal to minus q naught by 2 e power minus dt bracket open 1 plus b by under root of b squared minus k squared plus 1 minus b by under root of b squared minus k squared bracket close plus q naught. Sir, you can see this gets cancelled and therefore I get q is equal to q naught by 2 e power minus bt into 2 plus q naught. This 2 goes off to give me, where shall I write, sir? I will write it here. I will write it here. Okay. This expression will become q is equal to q naught 1 plus e to the power minus bt. Let us check whether the equation is correct. No, the equation is wrong because I have left this minus sign here. Therefore, if I put a minus sign here, this expression will not be of this form. Rather, it will be of the form q is equal to q naught 1 minus e to the power minus bt. Can also be written as q is equal to q naught 1 minus, in the place of d you can write r upon 2l. Therefore, e to the power minus r upon 2l into t. This is the expression for charge when the value of b squared is equal to k squared. What does this expression tell us? This expression represents a critically damped charge, which is neither oscillatory nor deadbeat. What does that exactly mean? I will let you know when I draw the graph for this. You must be convinced that if b squared is equal to k squared, we end up with an expression q is equal to q naught 1 minus e to the power minus r upon 2l by t, and there is no sign factor there, and therefore it cannot be oscillatory. Rather, it is critically damped. Why do I say critically damped? There is a negative exponential, and therefore it is not going to reach the maximum value. I will draw the graph and let you know at the end. Right now, not now. Right? Now I need to discuss the next case. I need this expression. For 7. Therefore, I am going to retain that on the board. Because I have finished b squared is equal to k squared case, I will rub this off and tell you what is the next case. I will rub this off now. Okay? My next case is 2 when b squared is greater than k squared. When b squared is greater than k squared, the square roots are real. Right? What does it mean? It means increasing till it attains a maximum value Q naught. Okay, sir. Such a charge, we call it as is said to be deadbeat. How it is represented, I will let you know when I draw the graph at the end. So second case becomes very simple, because b squared is greater than k squared. Naturally the roots will be real. When the roots are real, it goes to say that the charge keeps increasing till it attains a maximum value Q naught, and such a charge you call it as deadbeat. Now let us see the final case as well. I will rub this off to go into the final case. I will also rub this part because I need only equation 7. Okay? Now, case 3. B squared less than K squared, which means that is R squared by 4L squared less than 1 by AC. The roots are imaginary. Therefore, I am going to write this as, okay, J omega. I will write J as equal to under root of -1, and omega I will take it as K squared minus B squared, and therefore I will write J omega. Okay, I will tell you what it is, don't worry. I have this equation on board, so I are able to see it very clearly. Let me proceed it from here. I will rub also this off, so that I can utilize this space as well. Okay. Q minus Q naught by 2 into, okay, this bracket 1 plus B by J omega into e power minus B plus J omega T plus 1 minus B by J omega